Alright guys, we ran out of time, so I wanted to recap, and I forgot to record as well. So, we talked about what a scatter plot is. It relates two sets of data, and we can represent those two sets of data as ordered pairs. And when the points are plotted as a scatter plot, we can sometimes see if there's a correlation or relationship between the two sets of data. If in general it's going up from left to right, we could say there's a positive correlation. That means if they're both going that they're both going up or both going down. You can see a negative correlation. They're going down from left to right. That means as one goes down, one goes up. And if they're just scattered all around, you'll see that there's no correlation. You can't say in general they're all going, in the same direction or opposite directions or anything like that. That's just an extra one there. You can see an example here of how we represent this pairs of data as ordered pairs. So if they give you the sets of data in a table, age in years, height in inches. We talked originally last week about independent and dependent variables. Independent variables usually are time and distance, in this case age, some variation on time. And height is also distance, so that one's kind of tricky. But in this case, the age is the x coordinate, the height is the y coordinate. As the girls get older, their height changes. So you can see this set of data at 2 years old, this group of girls on average were 34 inches high. When they were 10 years old, you can see that on average they were 54 inches high. And we can write those pairs of data as an ordered pair, and that's an example there. 234, 337. You could write all of them as ordered pairs, and that's what they did here. And then plotted them on this graph. And when they just plot them on the graph, that's the scatter plot. The trend line is the line that you draw through those points. You try to go through as many points as possible, and then we call that the trend line or the line of best fit. And we can use that trend line to predict other values or future values based on that line that we've drawn, trend line on the graph, or an equation of that line that we write. And that's what we're talking about next. So from here, if we have a trend line, we can use the skills that we've been reviewing when we need to write the equation of a line based on 2 points. We can pick 2 points that our trend line goes through, find the slope, plug into point slope form, and then solve for y so we have it as in slope intercept form. Once we have it in that form, we can plug in different ages for x. So if I wanted to predict how old girls on average are at age 12 from this group, I would replace the x with 12 like they did here. So 2.5 times 12 plus 30 equals 60 inches, which is what we got when we predicted with our trend line that we drew over here. So about that. So the thing that we ran out of time for, and I wanted to go ahead and give you an example of, is how to do one problem from start to finish. So, there we go. So that's what we're going to do now. So it's talking about Ryan practices throwing darts, and from each distance below he throws 10 darts and records how many times he hits the center. So when he was 10 feet away from the target, he hit the center all 10 times. When he was 5 feet away, he only hit it 9 times. So you can see the length he was from the target, the number of times he hit the center. Remember, we can write all of these as ordered pairs, and that's what these represent, the x coordinate and the y coordinate. The number of times he hits the center depends on how far he is from the target. If he's 2 inches from the target, it makes sense he's going to hit the center of the target more than if he's 20 feet from the target. And so you see the example from his experiment here. So we're going to write these pairs of data as ordered pairs because we want to plot those to create our scatter plot. So the scatter plot represents this set of data from this table that they've given us. And I'm going to try to make sure I don't mess up plotting the points. Alright, so use the space at the right to make a scatter plot of the data. So that's what we're doing now. The x-axis is the girl's age in years, and the y-axis is the girl's height in inches. So we're going to go through and plot the ordered pairs. 2, 10. Each of these boxes represents 2 feet for the x coordinate and 2 years for the y coordinate. So we're going to go over 2 and up 10, plot our first data point. Over 5 and up 9, 2, 4, 6, 8, 9. Over 7 and up 8, 2, 4, 6, 8. Over 8 and up 10, 2, 4, 6, 8, 10. Oh, we did. I think I messed that one up. All right, so we've got 7 and 8. Now I need 8 and 6. That's the one I think I keep missing. So that's 2, 4, 6, 8, and up 6. 2, 4, 6. Now we're doing this one, 10 and 5, over 10 and up 2, 4, halfway between is 5. Now we're going to do 12, 1, 10, 12, up halfway, that's 1, and then 15, 2, over 15, up 2. So we have a set of data. It's not an exact straight line, but you can see that it's going down from left to right. So that's us making the scatter plot. That's what we just made. So the type of correlation, we can see it kind of goes down from left to right. Kind of looks like it's going down from left to right in general. So down from left to right is a negative correlation. And we're going to draw a trend line. So we want to draw a trend line, or our line is best fit through as many points as we can. So I'm going to kind of go, I feel like that's probably, let's see, that's probably the best I can do right there. So now I've drawn my trend line, that's the red line. Now, what equation represents your trend line? So I'm going to pick 2 of the points that I drew my actual line through to use to write the equation. So I need to write this equation, and I'm going to try to give myself some more room here by covering up this stuff. I want to write right below here. Okay. So what equation represents your trend line? So I'm going to pick 2 points that I drew my trend line through. So we're going to say 2, 10 and 15, 2. So those are my 2 points that I'm going to use. I'm going to use this points. 2, 10 and 15, 2. So I'm going to find the slope of my trend line by using the slope formula, y minus y over x minus x. So 10 minus 2 over 2 minus 15, and that's going to be 8 thirteenths. Oh, it's going to be 8 over negative 13, which is negative 8 thirteenths. So that's the slope of my line. Now I'm going to take that slope in one of my points, and I'm going to plug into point slope form because I need to write an equation. So I'm going to start in point slope form because I don't know what the y-intercept is, so I can't start there. I'm going to do y minus the y coordinate of one point, I'm picking the first one, equals the slope, negative 8 thirteenths times x minus the x coordinate of that point I picked to use. Alright, so now I'm going to distribute, and that's going to be negative 8 thirteenths x, because I'm multiplying here and here. Negative, negative, so that's going to be plus 16 thirteenths. Let's see. 10 minus 2 and 2 minus 15. Yep, that's right. Okay. And now I've got to solve for y. So I'm going to get rid of all this ugly fraction. We'll multiply everything by 13. So 13y minus 10 equals 13 times y, ooh, 13 times 10 is 130. Don't make the mistake I made. Use my arrows so I don't mess you guys up. There we go. So minus 130 equals, that's going to be negative 13 times 8. That's going to be negative 104 over 13, and that's x, plus 16 times 13 equals 208 over 13. So it looks pretty ugly right now, but 13y minus 130, 104 divided by 13 is actually going to be a whole number. It's going to be 8, so that equals negative 8x, and 208 divided by 13 is another whole number, so that's plus 16. So now we are going to isolate the y. So we're going to add 130 to both sides. And when we do, now we have 13y equals negative 8 times x plus 146. Now we've got to divide everything by 13. And when we do, we get y equals negative 8 13ths x plus, I'm going to say 146, ABC 13, with 11 and 13, and 3/13. I think we're just going to leave it like that. Let's turn it into a decimal. Plus 11.23. So let's turn that into a decimal as well. You have the option, if it's a real world problem, you can turn them into decimals. So let's do that, and we're going to round that to negative 0.62x plus 11.23. So this is the equation of the line that represents our trend line. So y equals negative 0.62x plus, I forget what it was, 11.23. Now, how many hits do you estimate Ryan would make from 6 feet? 6 feet, so feet is our x. So we're going to say, this question, number 5, just means, what is y when x is 15? I'm sorry, x is 6. So I'm going to take this equation and I'm going to plug in 6 for y. So y equals negative 0.62 times, not x now, but times 6 plus 11.23. And we're going to predict the number of times he's going to hit the center when he's 6 feet away. So let's use our calculator. Negative 0.62 times 6. It's negative 3.72 plus 11.23. So when he's 6 foot away, we'd expect for him to hit the center about 7.51 times. So on average, about 7.5 or 8 times. Let's look on our graph here and see. So how many hits do you estimate he would make? And we would say 7 to 8 hits, because 7.5 could be 7 or 8. So let's look. When x is 6 on our graph, let's see if it looks like it would be in that scatter plot somewhere. When x is 6, is y about 7.5? Well, let's go up and see. 2, 4, 6, and you can see it's about right. 7.5 would be almost right on our trend line. So that would be the answer to number 5. Okay, I hope that helps. I'll see you tomorrow.